Hello everyone, reporting today for Fun Robotics Network. I'm Abhas, and with me here is Team 14259 Turbo V8 from Pleasanton, California. They were your Northern California Winning Alliance first pick. Absolutely fantastic at MTI, and everyone watching, if you need an intake, you have to watch this Behind the Bot. They have the best intake and Into the Deep. So much going on here. Can't wait to jump into it on Behind the Bot. All right, guys, so talking about the intake, obviously this isn't just like the first one you came up with. What were some of the other designs considered, and what was the biggest reason you went with this one right here?
Yeah, sure. So originally in the season, we started off with the claw. We realized it's too susceptible to defense, so we knew we needed to switch to an active intake. Now, with the active intake, we originally had like side gecko wheels, but we found that it was also too susceptible to defense, and we couldn't properly like vector the element in without like the blocks spinning out and the blocks moving away. So eventually we came up with this design where we have top rollers, so nothing leaves through the sides. We have a wedge on one side, which helps us rotate into blocks, and also we have a counter roller, which allows our intake to like kind of vary at the angle we're at. And then if we deploy onto a block, the counter roller will pull the block in front of the intake, and then we can intake it.
All right, yeah, just so much to talk about here. Let's start with actuation. You guys have one of the fastest just spinning intakes I've seen. What RPM are you going at? How are you doing it?
Yeah, sure. So for intake, we have it's a bare motor. It's geared to around 2000 RPM using a GT2 Bully right here. And I guess in terms of like other things we're power transmitting through is we have a chain here that powers this axle, and then this axle has a round belt that powers our counter roller, and it's in an 8-figure.
Is that back axle that's powering the counter roller also contacting the samples, or is it just to do the power transmission for the bottom roller?
It's just to do the power transmission for the bottom roller. We didn't want the counter roller to interfere with this arc on the intake.
Got it. Yeah, and I've seen a lot of teams talk between using gears and belts versus just a twisted belt. How has that worked out for you guys? What are your thoughts there?
Oh yeah.
Yeah, so far we've seen that our belts have proven to be pretty good. Sometimes we do notice wear in our round belts over time, so we do have to replace that like every couple of matches. But other than that, power transmission through our chains and round belts have been pretty good.
Okay, and as far as making these go, I see like some weld or spot mark right here. How did you make these? Any tips for teams?
Yeah, so the round belts are actually made out of polyurethane. They come in a cable, and we use a solder to heat the tips of the polyurethane and then make a loop. Then we weld it together, and then we kind of just twist it to make the H shape, and then that's how we put it on the intake.
And when you're making like multiple or 3D printed guides or anything like that useful for you guys, or you guys have just got the process down without it?
Not really, just find a good tension, solder it, and then we're good to go.
Got it, yeah. Now, jumping into the wedge a little bit, I see teams pretty much every season, they start out with the symmetrical designs, then a lot of them will keep it, some will go to that asymmetrical design. At what point did you realize the wedge had to be asymmetrical, and why have it on the left side instead of the right?
So between the left side and the right side, mainly the space constraint because of the round belt is what made us decide to go with the left side. But the wedge really helps us with blocks that are completely horizontal. So when it's completely flat up against the intake, then it's really hard for it to go in. So what the wedge does is it allows us to move the block a bit to the side, thereby allowing our sweepers to move the sample in its long form orientation into the capsule.
Yeah, and talking a little bit about the orientation, like I see a lot of teams that when they have their intakes, they like to leave it like completely flat against the floor, but you guys don't do that at all. It's very angled upwards. Talk to me about that. How did you guys figure that out?
So we realized when the sub is extremely populated, it's hard to deploy the intake because this is a larger surface area. So we noticed that wedging the intake down this way allows us to enter the submersible pretty easily.
Yeah, got it. Now, talking a little bit about the geometry in the back here, I see just a lot more open space than I do typically from other teams. What locks or latches do you have going on there, and how have they progressed throughout the season?
Yeah, sure. So right here we have a latch in the back, so we use this to reject the block out of the back of our intake in case we get the wrong color. So for example, if we're on the red alliance, we pick up a blue alliance block, we'll open this latch, spin the intake, and then this will fly out the back. We also have these wedges in the back, which are not help to intake, but they actually help our claw transfer. It helps with the alignment of the claw.
So are those wedges in the back interacting with the claw or like some other part of the robot just to make sure you're centered properly?
Yeah, so these two wedges right here, they specifically interact with the claw. So there's a triangle shape on this claw that meshes with the wedge. And if the claw is slightly disaligned to the intake, like if the intake bounces because we're coming in with a lot of inertia from the extension, the closing of the claw motion will actually guide the claw into our intake where we can transfer, which is also what these cutouts on the side of our intake are for.
Awesome. Yeah. And last question regarding the color rejection or sample rejection. I know teams have had issues with like color sensors not being like fast enough or things like that. Was that something you guys dealt with? If so, how?
So our color sensor specifically has two modes of operation. It's either I2C or digital, and we chose the digital mode because it's much faster response times. Yeah.
So, okay. Yeah, and when using that digital mode, how did you guys tune it, or was it something you didn't have to tune too much?
So based on lighting conditions, we tune the bounds of the color sensor so we can get more accurate color readings. And yeah, it's something we tune on the sensor itself.
Awesome. Yeah. Last thing I want to ask about is the intake extension. It's just as fast as everything else you have going on. Is that two motor or single motor powered? And any tips you have for teams to make it super fast?
So our intake is powered by one motor here in the back underneath all the wiring. It's 1150 RPM motor connected to this spool over here. And it's strung on one side to reduce friction. And in case tensioning does get over tight or loose, it's only affecting one side and not both sides. So I think we found that pretty useful this season. Another thing that's unique about our extension is we're using SLA machined aluminum inserts over here. We found them to be pretty rigid. They don't break on impact. And if you've noticed our driving, it's pretty aggressive. So definitely keeps our extendo working.
Okay, so they're not aluminum inserts, but they're SLA inserts, you said? Or they are aluminum machined?
Yeah, they're aluminum 3D printed, sorry.
Oh, aluminum 3D printed, very cool. Okay, now jumping into the deposit, you guys are just up and down so quickly. Talk to me about counter springing and how you've worked with that this season.
So over here on our deposit mechanism, we have our stringing in the back and counter stringing in the front. We use bungee cords and they're strung continuously. So the extendo is powered by two 1150 RPM motors that you can see down here. They're connected to a 42 millimeter diameter spool. And yeah, that's pretty much it.
Awesome. Yeah, and as far as speed goes, have you guys been tracking your extension speed throughout the season, how it's changed, what's really made the biggest difference there?
I mean, previously in our V1 robot, we didn't have counter stringing and it used a pitching mechanism. So we've seen a significant improvement with just the bungee cords. And ever since our improvement from that, it's been pretty good.
Awesome. Yeah. Talking about the inserts over here, this red anodized, I know you said your intake inserts were SLA or were 3D printed aluminum. Are these machined aluminum or also 3D printed?
They're machined aluminum. They're from Robotics from Australia.
Yeah, and why use these? I mean, pretty much every other team is using 3D printed inserts. Why go for the aluminum?
They're just really rigid in general. They have decent machining tolls, and they also allow us to add both the bearings to the front and the back. They're just really accessible and easy to use.
Mm-hmm. So they have some tapped holes on the side, which make like the counter spring easy. So on like this side right here, there's a few tapped holes. Also, we snapped one at like NorCal Regionals, and we didn't want to repeat that for Worlds.
A 3D printed insert at
Yeah.
NorCal. Okay, got it. Yeah, that's a huge change. Now, next thing I want to talk about is the net you guys have going on here. Walk me through that. Has it been just a beginning of the season addition, or was there something specific that spurred it?
Yeah, so I think at our League Meet 1 tournament, like we knew this from the start, but we actually did get a block stuck in our robot. Luckily, we were able to get it out, but we knew that we wouldn't be as fortunate throughout the season if that happened. So since then, for all of our competitions, we've been adding a net that kind of guides to the center of the robot. So if a sample were to fall here, it's angled downwards, and then it would fall kind of onto the floor, and then over here, it would guide it towards the inside so we wouldn't get it stuck.
Yeah, now jumping into some strategy and software maybe side, your cycles are just so fast on that samples. What are some of the biggest things that influence that?
So one thing we did add is an auto drive feature. So the second driver is able to choose if we enable auto drive or not. And what we do is when the robot automatically detects a sample in the intake, it retracts the transfer, but also starts driving to the basket, which allows faster response times instead of the driver having to manually.
And so how does pathing work on that, right? Because you're not intaking from the same place every single time. So what is the pathing like there?
So based on which side of the sub we intake on, the second driver can input that so it knows which way to back out so it doesn't collide with any of the submersible.
Awesome. Yeah. And, you know, how, given in a given qualification match, would you say you use it like half the time, 100% of the time? How often are you using
I think really most of the time.
Okay, wow, yeah, that's fantastic. Now, as far as depositing strategy goes, you know, we see you guys just stacking. You fill it up first, and then you keep putting it on, keep putting it on, keep putting it on. How did you develop these so precise placements, and what's going on there? What can teams learn from you guys on that front?
Yeah, sure. So like when we start depositing, we generally just have our arm up at like a static location and say here. But when we notice that the high bucket is getting full, we change our positioning. We move the slides up a bit. We angle the wrist in a way where we can kind of stack better. And the second driver also has manual control over the slide's height and the wrist angle to like kind of get more precise depositing locations.
Awesome, yeah. Another thing I want to talk about is the transfer. I saw a couple of your guys' matches, you know, you'll go to pick up the sample, miss it initially, but even in autonomous, you'll go back down and pick it up. What's the logic like there? What's an easy way teams can do the same thing and learn from you guys?
So what we do here in autonomous, right? We do a transfer sequence, and once the slides reach all the way up and it still sees a color or a block in the chamber, it knows that it's still there and it failed transfer. So it goes to the previous state in our finite state machine and then re-grabs it and then goes back up again.
Fantastic. Yeah, and finally touching on those autonomous paths again, for the path generation, is that Roadrunner, Pedro pathing something you guys have developed? Talk to us about that really quick.
Yeah, so we had a custom PID to point implementation with a combination of pure pursuit. So for some movements where we want it to be more precise and we're not trying to do a curved movement just straight to point accurate, we use a PID to point. But for movements from like the submersible where you want like a nice smooth continuous path, we will use our pure pursuit and then switch back to PID at the end to get a nice stop.
Yeah, that's really impressive, and obviously it's been working out super well with those cycle and samples. TURBΩ V8, thank you guys so much. I mean, just the sample kings in this Into the Deep season, it's really fantastic to see how fast you're able to go and how consistently. So reporting for Fun Robotics Network, I'm Abhas, and this is Team 14259 TURBΩ V8. Thank you.